force. Think of it as tug of war. And so underneath yours, when you draw these arrows, you're going to write underneath it to remind you, like tug of war. And I'll show you in a second. Over here, you can think of that one like, if you look, the arrows are pointed toward each other, but they're still going in opposite directions. Think of that one like arm wrestling. When you're arm wrestling, both of your forces are pushing toward that middle. One is pushing to the left, one is pushing to the right. These here look pretty balanced, so if you were arm wrestling, that means that those arms wouldn't be moving at all. They'd be stuck at the top. You know how you get those people just struggling so bad they start to shake and turn red and pale and everything else. That's what's going on here. They're at a stalemate with their arm wrestling right here. So when you draw these two arrows here on your paper, you're going to say like arm wrestling. All right. Let's continue on to our types of forces. You have two types of forces. You have your balanced forces, which means they're even. Alright, so that should be number 4. You're going to go ahead and write that in for number 4. Balanced forces. Alright, the object doesn't change its motion. The object does not change its motion when the forces are balanced. So that means if something is still, it's going to stay still, because the forces are balanced. If something is moving, it's going to keep moving because the forces are balanced. I'll give you a couple of examples. A shoe laying on the ground. The forces are balanced, so that shoe isn't going to move. The only thing that can move that shoe is if the forces become unbalanced. How can they become unbalanced? You come and you kick that shoe to move it across, then it's no longer balanced. An example of balanced forces that is going to continue its motion is, think about for a second the Earth's revolution around the sun. It's at a constant speed. The forces are balanced, so it's going to remain at that constant speed. The only way it wouldn't remain at that constant speed is if the forces somehow become unbalanced. Maybe a meteor comes and hits something or something and knocks us off. But as long as those forces are balanced, the Earth is going to continue to revolve around the sun. So two different examples. One of something being still and going to remain still because the forces are balanced. And another example is something moving and going to keep moving because the forces are balanced. The other type of force is your unbalanced force. So write that in on number 4 as well on your foldable. Unbalanced force. Alright, and your unbalanced forces, like I said, they do change an object's motion. If you had some person or a little brother, a little sister, you had something laying perfectly still, it wasn't bothering anybody, and they come and knock it out the way or move it or something, well, they just caused the unbalanced force to act on that object by moving it. It was balanced, it was just sitting there. Alright? Or if, like I said, the Earth is revolving around the sun, or the moon is revolving around the Earth. You can look at it either way. If something comes through, a meteor or something, and hits that moon, it can change that motion, cause it to slow down, speed up, or stop. You know, that would be an unbalanced force that acts on it. It changes an object's motion. And here's an example of an unbalanced force. Alright, the wall acted upon the car. And what happened? The guy went flying out of the car. Pretty cool, huh? The car and the person in the car are moving. The force on the wall changes the motion of both the car and the person. Alright, look at the pictures and decide if the forces are balanced or not balanced, and what happens to the motion of the object. And if you look inside, I guess we'll come back to number 5. We can look inside to see these pictures. Alright, number 6 says, how does the picture demonstrate balanced forces? You're going to tell me that. How do you think that picture of these two people, and it's in your foldable, pushing against the box, is demonstrating a balanced force? What's going on? Alright, if you said the box isn't moving, you'd be correct. We know that it's balanced forces because the arrows are the same size. Okay, so that tells me that the two guys have the same force. So if they have the same force, that means that force is balanced. So if it's a balanced force, it's not going to move. So make sure you write that on your paper for that picture. It's a balanced force, so there will be no motion. And we know this because the two arrows are the same size, and they're going in opposite directions. So they're basically canceling each other out. Look at that soccer ball though. One person or one force is pushing that soccer ball upward, while another one is pushing it to the right. So you can see that it's going to go upward, but the force of it is going to carry it way over to the right, because that force, if you look at the arrow, the force that's pushing it to the right is greater than that force that's pushing it up. So they both will happen because they're not acting against each other. So they both will happen. It will go up, but it will go a further distance to the right than it will go up in the air, because the force, since that arrow is bigger, is greater pushing that ball to the right for the soccer ball. Okay, and what you're also telling me is you're labeling whether these forces are balanced or unbalanced, but you're also telling me whether, according to your foldable, you're also telling me whether the forces are pushing in the same or opposite directions. Now I'll let you do those last 3 on your own. 1, 2, and 3, and then we'll check it when I return to school. So give you a couple of minutes to work on that, or you can just put it to the side for now, and we'll come back. You'll come back to it after the video is complete. All right. Is work being done? The way that we know this, we have to figure out, did the object move? Number 1. Was the force in the same direction the object moved? Let's think about that for a second. First of all, the object had to have moved for work to be done. But not only did that object have to move, the force has to be going in the same direction as the object. So if there's a big crate on the ground and I'm pushing it across the floor, that's defined as work, because I'm pushing it in the same direction that it's moving. Well, how can it not be, Coach Smith? Think of it this way. Suppose I was carrying that box. Well, my force is pushing upward to hold that box in the air, but I'm walking across the floor, so that object, that box, is either moving to the right or to the left, whichever direction I'm walking. So no matter how tired you get, that would be an example of no work taking place. Because number one, your object has to move, which is moving, but your force has to be going in the same direction. And since my force is holding the box up, so pushing upward, and that object is moving to the left or right, then no work is being done. They both have to happen. The object has to move, and the force has to be in the same direction. And I'll show you guys that an example when I return to class. Alright, it says, would you like to demonstrate work being done on an object? We'll get to those demonstrations as soon as I return. Alright, thank you for taking the time to watch the video. And for the rest of the time, you're going to study back over that slide and make sure you know what your work is, know what your force is, know how to tell if they're going the same and opposite direction, because we're going to do a station lab when I return on this later this week. So you have to make sure you're prepared. All of you are capable of doing this. Make me proud, be good, and keep learning. Coach Smith loves you. Peace.